Okay. Hello, everybody, and good morning, good evening, good afternoon, and welcome to a special Going Meta episode. This is the season 3, episode 9. I'm extremely happy to welcome Jesus on this stage again. Jesus is our CTO AI, and you know him if you watched a couple of episodes before. If you dove ever into ontologies and semantics, you probably also heard about him. So he's a familiar face, but I'm today also happy about another very familiar face, Will Lyon. Will, you have maybe seen him on things like context graphs, agent memory in the recent past, and that's been amazing work that's been done by Will and driven by Will as one of our product leads here at Neo4j. So I'm super excited to have you two join this Going Meta episode. And we decided on the title of Shape Agent Memory with Ontology. So no better way of combining the two forces, I would say, behind this agent memories will ontologies is Jesus. And so we said, okay, let's bring it all together and do an episode.
Love it.
Yeah, that sounds really exciting. Yeah, no, it's really good to have you. Well, I'm really looking forward to this session, and well, this is a topic that we've touched, superficially on. I'm looking forward to diving deeper and see how these two components, come together.
Exactly. Yeah. As always, this is live as we do it. So if you have any feedback, any comments, anything you'd like to see more about, then let us know in chat. You can always take a break and dive into some Q&A. If you watch this afterwards, obviously the comment function or the section rather in YouTube is the place where you drop in your notes or your comments, and we'll have a look at that later on. But yeah, today we go into the topic of agent memories with ontologies. We discussed this a little bit up front in a small group chat this morning, basically for how do we want to do it and how do we want to drive it. I think we landed on that. Will you give a little intro with a few slides, and then we discuss a couple of things? Is that that's still what we're going to do?
You make it sound like we just come up with this on the fly here, and that this is not a well choreographed show. Yeah, that sounds good with me. I have a couple slides I can go through, maybe just to kind of set the context. But yeah, I mean, I think really anything we can do to have a lively discussion, I think might be helpful. I guess maybe just to kick us off, and appreciate feedback or chat from folks online. I'm curious, like, how folks think of agent memory. Jesus, and Alex did, I think, an episode on this, talking about some of the things we're doing with agent memory and Neo4j, but maybe just to take a step back, here's kind of how we think of agent data, I guess maybe at a higher level than just talking about memory, is really for your agents to be successful. These are, I think, the different types of data that they need, and really this is more than data. We talk about the knowledge layer, right? Because this extends beyond domain data, right? When we say data, that's typically what we're talking about, but there are all kinds of metadata around the domain data, right? And I think memory is maybe a good category of that. So the way we think about this internally when we're talking about sort of this knowledge layer for agents, memory is in this category of sort of data about the data, right? Like what can we learn from our interactions with the user and the agent? How can we inspect kind of the reasoning phases, the decision traces, both of human actors and agents, and that can inform how our agent reasons and plans going forward. Does that make sense? Is that kind of, I guess, maybe how we think of agent memory in sort of this context?
Yeah, I like that. So basically, the probably the part to the left is the one that's more actively created by us, and the graph to the right is the one that's kind of built as we use our graph, as we build applications, as we build tools, as agents interact with the graph, and they leave that trace that also contributes to enriching this knowledge layer, because that's the way of thinking about it, I guess.
Totally. And one thing I think that would be really interesting for us to dive into today is how this idea of ontologies, how like a domain specific data model, like how that can drive the column on the right, how that can drive our agent memory. Because I think that's really important. Like we're going to often work with unstructured data when we're working with agents, right? A lot of this can be conversational, and so what we'll see today is some of the work we've done on how we can sort of go from this maybe unstructured data, maybe conversational, maybe document based, whatever, but how we can use ontologies and our domain models to sort of help connect our domain data and the agent memory that we're surfacing, right? I think that's an important aspect, I guess, of how we expose knowledge to our agents, I guess, is maybe one way to think of that.
Got it. So the idea in a way is kind of we're being selective, or we're informing the way our agents build their memory, right? So we're giving them information on what we care about in the form of ontologies or domain models, so that they can be selective on what they distill out of these conversations, out of these interactions, out of these unstructured data, and build a memory that's meaningful and useful to us, rather than going blind and just picking. Although there's kind of, I mean, I wouldn't call it blind, right? Then probably you're going to be talking about what's the default mode if we don't provide that, because there might be a case when that may happen, right?
Yeah, I think what you said there about informing our agents what we care about, and that should drive what they remember. I think that's kind of the key. I don't know, maybe way to think about how we apply ontologies and domain models to agent memory is like, yeah, we're saying, hey, here's my domain model. Maybe I'm I don't know, financial services analyst, whatever, right? And so the things that I care about are going to be like accounts and transactions and my customers and assets and these sorts of things. I probably don't care if a calendar reminder comes in to, I don't know, like use the example of like, I don't know, picking up my kid at 3:00 from school, right? Like my financial services agent probably shouldn't remember that. Like that isn't really relevant. So exactly, in a world where there's lots of unstructured data, and our job is to kind of make meaning and understanding. I think an important piece of that is having a domain specific ontology that we can say, this is the important shape of data that drives my business.
Yeah. And when, I mean, what I was meaning when there's kind of when we don't define that, because I suppose this in the ontologies world, there's this idea of I don't know, high level ontologies, but there's the notion of, probably if you don't tell me anything else, I know that there's people, that there's objects, that there's events, that there's locations. So there's kind of this default idea, right, of the pole style model or something like that. So if you don't tell me something else, maybe we'll go with this kind of high level buckets or categories that would capture. Is that reasonable as a kind of a default behavior, or is that?
Totally, and that's exactly what we use. I think maybe that have a slide coming up on that. Yeah, I mean, we can talk about that here. So like one of the manifestations of our agent memory tooling, and I think you guys talked about this last time, is this Python package, Near-Future Agent Memory, that implements a lot of the concepts that you guys talked about last time. This idea of short-term, long-term reasoning memory, right? So constructing kind of a knowledge graph from unstructured data that we were just speaking about, and the question of like, how do you go from this unstructured data to the knowledge graph, right? And where does that like default ontology come from that Jesus was talking about? And that's exactly right. We use this poll model, which is person, organization, location, event. We extend a little bit with poll plus O is kind of what we call it to capture all of these pieces. And this is exactly the default entity model. So we're saying, these are the things that we're going to look for in the unstructured data. These are the node labels that we're going to use as we structure this. But by all means, this should be extended with your specific domain model. And so the way this works is essentially Neo4j agent memory has like 3 high-level abstractions for the types of memory, right? Short term, these are like conversations and the messages in the conversation. Long term, this is the entity graph, sort of the knowledge graph extracted out, or can also be built explicitly, but typically this is extracted out of conversational data. These are essentially the entities that you're mentioned that are, and how those entities are connected. And this is where that domain model, this is where that ontology is applied, is this process of how we go from this unstructured data through this entity extraction and resolution pipeline to end up at this this connected graph, right, where we have the messages. This is just the short-term memory piece, your messages as they're connected to a conversation, but then we're extracting out and building the long-term memory of the entities that you're mentioned, how they're connected. This is where your domain model is applied. And one thing we haven't talked about yet is this reasoning memory. This is kind of inspecting the reasoning traces, the execution plan that the agent comes up with, the tool calls, and observability information into those tool calls. How many LLM tokens did it burn? What was the result of the tool call? This sort of thing. And so these together, these 3 types of agent memory together make this connected graph of knowledge that is then made available to your agent during its reasoning phase.
Makes sense. That's great. And so I one of the things, and I don't know if you were planning to go into that, but one of the slides before, so the kind of long-term memory is like these sort of extracted knowledge graph out of what we exchange in conversations or what we provide in documents, applying the ontology that we define. I think I briefly saw past that it's not always going to be, although these days we default to LLMs as doing that, right? So when we've done these in these series, we tend to, we'll go with an LLM, which is kind of the general purpose thing. It may or may not be the best or the most, the most cost effective. That's probably certainly not. But I'm curious if we can spend a moment on that and whether there is any kind of limitation in terms of precisely what we're talking about today. I mean, can I still use my ontology to inform the extraction with other types of models that may not be, large language models?
Yeah, that's a really good point, and that's something that, as building the agent memory tooling, something we've been very cognizant of is just kind of the I don't know, token usage, right? And I think the agent memory initiative, that this is part of a larger product initiative at Neo4j that we refer to as the agent brain. So this is like tools and services built on top of Neo4j to make it easier to build and operate your agents and to do this more efficiently. Like this, I think token efficiency, being able to do more complex operations with your agents with less tokens is going to be like even more important going forward. And so that's that token efficiency is one of the things that is an important, I'd say, like guiding principle as we're building out our agent brain portfolio of products at Neo4j. And so one of the things we looked at was exactly this: how do we power entity extraction and entity resolution as we're going from unstructured conversational document data to the knowledge graph. And as Jesus said, like, yes, we can use an LLM for that. LLMs are very good at taking unstructured data. We can give it, here's the shape I want to end up with, and kind of extract that. LLMs are pretty good at that, but they're very slow and they're very expensive. And so building this out, and especially looking at some of the benchmarks we were doing of, here's like a massive data set, let's drive this through our agent memory tooling. It gets very slow and very expensive if you're only using the LLM to, even if you're batching this and however. And so our agent memory tooling has this kind of 3-stage pipeline. And so the first stage is to use more traditional NLP techniques, statistical methods. In the Python world, we use the spaCy package. This is a good one. And so this is statistical and runs locally. So this is essentially free. And then the second phase uses small local models. We like the Gliner models. These are fine-tuned models, specifically fine-tuned on extraction. And there's a similar model called GliRel for extracting relationships between entities. These are small models that can run on CPU. So these are essentially free. You can run them on your own hardware. And then the fallback is to the LLM for, this is going to give us the most accuracy for extraction and resolution. But yeah, at each phase of these, so Gliner, we're able to apply kind of the data model, similar with spaCy. It's, the statistical methods, you get kind of the high level, like this is, person, organization, that sort of thing. And so we kind of apply like a post filter sort of hints at that stage. But yeah, but exactly. So at each of those phases, we do some sort of like merge strategy, and we have, again, a similar pipeline for resolution, different ways of looking at resolution across semantic matching with vectors and this sort of thing. We even do LLM fallback for resolution. But yeah, but that's the idea, and we want these to be pluggable, because I think there's cases where you're certainly will prefer highest accuracy versus cost and time. So but that's sort of the idea of how those pieces fit together.
And you refer to them as phases, and they're mentioned there as stages. So it's not like I choose to go with one or the other. So you apply them in sequence, and if you get satisfactory results, then you can skip the later. Is that how it behaves?
Yeah, it's all configurable, and so you can turn off the LLM and you can only do like essentially what's like the free and local version. And this is good for air gapped too. Like if you don't want to send your data to the LLM, or if you want to use local LLM, like whatever. But I think that's a common case too. Is like, oh yeah, I need to be air gapped. I need everything to run locally, and so therefore I'm just going to use spaCy and Gliner. Yeah, exactly.
Cool.
And are these like Gliner, are these like general purpose models, or would you say there is benefit of using a special, small model for certain, optimized for certain, let's say, industry, or maybe certain topics or certain fields? Is that beneficial, or would you say this is not really necessary in this point of the pipeline?
That's something we're starting to look at, is fine tuning these small models per domain. For now, so Gliner 2 is like a fine tuned model that's publicly released by the team for general purpose extraction. I think in the paper they look at like scientific or like very specific domains where that may be beneficial. Something we're just starting to look at. But yeah, that could certainly be interesting if you have very like scientific or very domain specific terminology or these sorts of things. That may be an interesting advantage.
Yeah, I can totally see that. Last episode we did like this with certain case files with healthcare, and we said, okay, here is the context, and here's what we talk about, and here's what they what example cases should look like, and then we kind of like had our own little small model basically from that, and that then helped create the rest going forward.
Cool. So we talked about kind of the rough data model and how these three types of memory are connected. We talked about kind of these three abstractions, the short-term, long-term reasoning memory. I guess maybe the other thing that's worth pointing out is that a lot of the agent memory tooling and our agent brain tooling is about enabling some of the like very powerful, sophisticated things we can do with Neo4j in a lot of these other agent frameworks and other tooling. And so, for example, we invested a lot in making sure we support the Google ecosystem through Google ADK, AWS through Strands and Bedrock and Microsoft Agent Framework as well. So we have integrations that we publish that are specific. That specifically, I guess maybe a way to phrase this is like wiring up the memory abstractions that these agent frameworks expose to like this API for agent memory, right? Because by default, all these agent frameworks have their own sort of abstraction of memory, right? And they all have some default level. It's typically like in memory based or something like that as just a starting point. And so to be able to leverage Neo4j for agent memory, we have these like framework specific integrations that we publish as well.
And in general, do they have like simpler kind of types of abstraction for memory, or do they define these three types of memory? Are we aligned with the way these frameworks think of memory, or is our approach richer?
Yeah, that's a great one. The literature and the approaches to agent memory are quite varied. I'd say there isn't kind of a canonical this is what we mean by agent memory even, and I think it's very much a experimental area. I think one of the biggest challenges is how do you go from like single user, single agent memory system where you may be running, locally. So like Claude Code is a good example, right? So Claude Code is this like agent harness for the Claude Anthropic models, and oftentimes you're using it on your laptop as a single user to help you write code, right? And it has a memory system that's typically file based. It's like some markdown files, and it's smart enough to group them by folder, so we can kind of treat these folders as topic. But and that works for like a single user. But what happens when you have like a system that has hundreds or thousands of agents that are running in the cloud, and you all kind of want to have them in a shared memory system they're all contributing to and learning from that memory layer? That leads you to like very different choices in how you might structure your memory system. And so I'd say being able to bridge that gap of like, yes, I want to be able to have very like rich local memory personalized to a single user, and file system is based for that, because agents are very good at exploring the file system, right? Like they know how to do grep, they know how to navigate folders, but when you give them a database, because we have like hundreds of agents, we need to manage concurrency and all of these sorts of things, then I think the abstractions become a bit more complex. So anyway, I think it's still like in flux, and there are some like really interesting systems evolving for things like how do you manage I think Anthropic calls this a dream state, or master folks have a feature they called observational memory that we've drawn some inspiration from. You have this sort of background curation job as well. That's sort of surfacing the summarization of memories over time.
Yeah, no, it's cool. What we experimented with here, I mean, the first was the episode that you referred to was, really a basic introduction. So we were just going over a Python notebook, and we just literally imported the package directly. But in the other one, we used the MCP server version of it. So we built it into the ontology generation skill that Alex was talking about before. Well, it was implemented as a skill, but basically it was the process of generating an ontology out of some collection of requirements in the form of competency questions and other things, some sample data, and eventually some pre-existing models. And with all that, it went into kind of a loop of decisions, modeling decisions with some human input, and the final product was an ontology. And we thought that it was a great candidate for capturing all these reasoning traces, because every modeling decision is a decision trace, right? So what was great was that the final product is, of course, a rich ontology that's well documented and everything. But what we have in addition to that is a reasoning memory in Neo4j that keeps all these decisions that we thought that would be really useful when 6 months down the line the ontology is going to evolve. And you don't only have the ontology, you have all the knowledge that was acquired and all the the reasoning that went into the process of modeling. So that was a great implementation that we came up with, and we used the MCP server through, I think it was we used Cloud Desktop for that example, but it was one of the
Neat. I like that. Maybe, maybe we should take a look too at something maybe a little more hands-on. Have we seen enough slides? I think
that's good as an introduction. I think we have a great context now. So yeah, let's go look at
we have one question on over at LinkedIn from Samuel, and maybe we take that in between. Samuel wants to know if we have to build an extra database specifically to record the agent memory. Is that something, or where does the agent memory go from build? Or maybe you just show this in a second. I don't know, but
Yeah, I think if you're already using Neo4j, like let's say you have your domain data in Neo4j, you have a couple of choices, right? Like you could create an additional database and just store your agent memory separate from your domain data. You could also store that in the same Neo4j database if you want your sort of memory data and your domain data to be co-located and maybe treat that as like a separate like logical graph, something like that. But I would say you don't need to be already using Neo4j for your domain data to usefully make use of Neo4j for agent memory, if that makes sense. What are some of the common patterns that you see, Jesus? How would you answer that?
Yeah, that's I would say that the default is having it in a separate. I was actually going to ask the question, which cases would it make sense? Because I suppose there's additional concerns in terms of access control and governance and all that, which may come into play. So I would say the default is to have a separate one. Of course, in the world that we live, typically your data lives in Neo4j, and when you build an agent, you have an additional database that sit next to the other one. And I mean, there might be situations where I don't know if scenarios like I'm thinking of when would you and how would you combine the two, like having some sort of composite database that enables you querying across in some cases. Would that make sense? But maybe that's kind of a follow-up discussion. But the default is having two separate databases, one to store the memory and another one. But it's interesting, what you just said, because yes, I mean, it doesn't matter really where data lives. I mean, whenever you're building an agent, then you want to have memory persisted in a rich way and a kind of a model independent way as well. I guess Neo4j is certainly an option without having to impose your data has to live in a graph as well. It's just the memory part, right? So that's
for sure. I think at a fundamental level, like one of the big benefits of the graph is being able to combine data from multiple data sets and query across them. And if you leverage value from being able to combine and query across your agent memory and your domain data, that's interesting to pursue, but that's not always going to be the case. Yeah. One final slide before we jump into looking at some hands-on stuff that I thought would be useful. So we've talked about like Python library. I talked a little bit about this create context graph like scaffolder, and I'm going to show a hosted version of our agent memory tooling in a second here. So I thought it might be useful to show just kind of how do these pieces fit together. And so this is hopefully a useful slide. Hopefully this isn't too confusing what's going on here. So if you've seen maybe some of these pieces before, I mentioned earlier this idea of like the agent brain initiative, like tools and services built on top of Neo4j to make it easier to build and operate your agents. And agent memory is one of those initiatives that has a few different pieces. One of those we talked about is the Python client. And this, I think, was one of our earlier initiatives within Neo4j Labs to implement the things I talked about earlier, like the entity extraction pipeline. This is where the MCP tools for agent memory live. But what we found is, that Python package was great. It's a bit heavy, perhaps, right? Because you were talking about a memory system that's still going to run in the code base of your agent app code, right? And so if we're also running the entity extraction pipeline and all of that in that service, maybe that's not always the right architecture you want. What about the other language ecosystems beyond Python, and also in ecosystems like we're building the integration for Salesforce for Agentforce for their memory system. And Salesforce doesn't have like a generic compute layer, and so you need somewhere to run this memory layer. And so for that reason, we built the Neo4j Agent Memory Service within Neo4j Labs. So this is a newer labs initiative. This is live now, and I'll show a demo of it soon. But basically, the idea here is the same concepts that we talked about that we exist in the Python package. This like domain-specific ontology-driven entity extraction, the integrations with the different frameworks. All of that logic lives in a hosted service that we call NAMS. We'll can't even manage your Neo4j instances. And so now the Python package can act as a client essentially for NAMS, so it can integrate with any of those agent frameworks, but in a much lighter way because it's just a client for the hosted service. So that entity extraction stuff, running like the Gliner model, serving the MCP tools, all of that exists in this hosted service. And now we also publish, for example, like a TypeScript client that has integrations with all of the TypeScript agent frameworks and that sort of thing. So anyway, so that and then the other one is the create context graph, which is like a scaffolder. So you can essentially like run one command, and the idea is to scaffold out kind of a full stack application that has the memory system, the decision tracing from documents, the front end piece, all of those sorts of things. So anyway, that's how it's meant to fit together.
That's great. There's an additional question that we can use to transition to the hands-on part, but it's about like time to live and how do we maybe get rid of older memory. I mean, I can read as is there a way to keep the memory up to date, so how older memory and information is not used instead of newer ones. So is there any support for that in the Neo4j agent memory at the moment?
Yeah, that's a great question, and that's exactly what we were talking about. This idea of the observational memory stuff. So being able to, sort of have a background process. Anthropic calls this the dream phase, I think, which is background process that's kind of reflecting on your memories over time. There's some like time decay element to this too, and that's the approach we're taking for call it curation. And I can show an example of what that looks like in a second. So this is NAMS, or the Neo4j Agent Memory Service. This is available now, so anyone can try this out. It's a free service, part of our labs initiative. So this is not officially supported, bit experimental, but I think it's useful to be able to surface and build agent memory and see how these integrations work. So maybe we can take a little tour of this.
Cool.
So I dropped a link so anyone can sign in, memory.neo4jlabs.com. I think I'm already signed in.
Put it
here
in chat, also in the video description, if anybody wants to look at this later.
Perfect. So the first thing we see on this dashboard here is just kind of like a snapshot of the different services here, and so this is, you can think of this as kind of like a hosted version of the functionality that we talked about that exists in the Python package of agent memory. So one thing is serving a REST API and an MCP endpoints. So this is meant to provide endpoints for our agents to interact with. This is we'll see some UI tooling and whatnot, but primarily like we want our agents to interact with this memory system either through the MCP tools or through the REST API that we've published. And then there's IME extraction and this NAMS memory worker. This is the scalable worker that actually does the IME extraction and resolution. NAMS tenants, this is kind of like the data layer. So this is just showing the services that we have running. If we look at the docs here, we can see the REST API, and aside from things like auth and whatnot, this roughly matches the abstractions that we saw earlier for short-term memory around conversation, long-term memory, which are the entities extracted out, observational memory. This is the background, which we'll come back to, and then the reasoning memory. That's kind of the third piece, which are like your agent traces and that sort of thing. And the MCP tools match that as well. So tools for working with short-term, long-term, and reasoning memory that your agent can work with directly. Cool. So maybe, and I have some memories loaded already, but maybe we can go through this from the beginning to sort of see what this looks like. Let me zoom out a bit. So let me create a new workspace, and we'll call this going meta. And I can either provide my own database, or I can provision a database in NAMS, just use like a free tier instance if we do that. So, but I can also just plug in, if I'm using my own Aura instance or a hosted instance somewhere, plug that in. But we'll spin up a free tier here. And so this is going to create just a free tier database that we can use for our memory system. And then what it's doing now is applying the database constraints that we use for the memory system. And that matches we saw that earlier, kind of the where we saw the connected graph of short-term, long-term, and reasoning memory. Cool. Okay, so now we have a new workspace, and we spun up a database specifically for that. I'm going to download my credentials again, just so we have that. And so the first thing, like all of this is empty, right? Like there's no data in here. This is going through the curl commands to create a conversation and post it. But maybe we can just do this in the doc. So the first thing,
a little bit, Will. It's a tiny bit small.
Sure thing. Let me zoom in a bit. Cool. So the first thing our agent would do is create a conversation. Right. So it would make a post to create a conversation. I think I need to. Yep. So we have an auth key. So we're going to create a new conversation. Put this off to the side here, because we need that later. So we have a new conversation, and then we would need to send a message, right? So we have some interaction with our agent. We want to post that message to our memory system so that we can keep track of that. And so here we're going to add a message. And we have our auth key. We need the ID of the message, or the ID of the conversation, rather. And then this is going to be the user. And let's say, how about Will, Alex, and Jesus are presenting an episode of Going Meta, which is the world's greatest podcast. Something like that. Right. And so that returns immediately. And this is just meant to be like, this is like something async that we would capture. And now if we go back to the dashboard, we go to our memory browser. Let's see, we may have, what can we look at? We can see, here we go. Our events, we have one still pending. So this message was sent. Give it a refresh there. There we go. So this message was sent and triggered this extraction job. And now we can see we have 4 entities. If we go into our memory browser, we can see that, okay, cool. We have this Going Meta. We have 3 entities that were extracted. Yep, cool. If we scroll out a bit, we have a bug here. We're not showing our relationships in here, but we can see this is our conversation node, and it has a message. So we capture the message. We generate an embedding of the message, and then all of these entities also are sort of extracted out. We're representing, like, okay, Jesus participated in, the Going Meta podcast. So now, over time, like, this is the knowledge graph that's built up from the unstructured data, right, of our messages. And this is what's built up from one single message. This is now made available to our agent through MCP tools. To, if I said, what is relevant context for Jesus? What do I know about Jesus? Like this sort of thing, we can now traverse this graph to provide relevant memory for the agent. That's the general idea, right? And so I basically provision an API key and drop in one of the agent integrations that I showed earlier, drop in my NAMS API key, and my agent, essentially with a couple lines of code, now has access to this functionality of creating this knowledge graph and making tools available to
Mhm.
to provide that like the most recent most relevant context for the agent from the knowledge graph.
Got it. And there you applied by default this poll model, right? So this is identifying persons, events, I guess.
Exactly.
Okay.
Yeah, exactly. And so here, these are the person nodes. Going meta was classified as an organization, which I guess that fits here, podcast. And then we didn't have any locations, concepts, tools, right? Now that is, like I said, just our default ontology because, and here's, if we go into the ontologies tab, we can see kind of the ontology library and this editor thing. So maybe we can dive into this because I think this is kind of an interesting piece here.
Yeah.
So where's our default? Which one do we have active here? Well, let's say we wanted to add I don't know, let's say like healthcare or something, right? So there's this ontology library. And so I have a healthcare option in here. So I can choose healthcare. I have patients, encounters. That seems reasonable, but and I have kind of, all these to choose from. Like let's talk about maybe where do these come from is maybe like a good question. So one of the projects that I mentioned on that slide of the agent memory, like Neo4j initiatives, one was create context graph. Create context graph is this project. The idea is to, with a single command, to be able to scaffold out a like domain specific context graph application. And so this was, really meant to look at how could I, for example, like maybe surface the decision traces from a Google conversation thread, or maybe if I wanted to import my where's the Claude Code one is a good example. Maybe I wanted to import the agent traces, the sessions of like a Claude Code session, because I want to construct a context graph of sort of like the coding decisions that went into to building this. And this is really being able to build a context graph with real world data, I think was a big part of the goal of create context graph. But we needed like domain specific data models, domain specific ontologies to be able to do that. And so that was a big part of in create context graph. There are, let me find the custom ontology. There are these ontologies that include like the domain model, but also reasoning traces and documents that we use. So you can think of it as like seed data for creating the context graph. And so we took those as just kind of the starting point for the ontology library. So we'll like, this can be very much extended. We'll see how to import your own. But by default, we just serve those that we have available in create context graph. So let's say I want the healthcare ontology, right? I can clone this. This now becomes a workspace ontology. My zooming is a little, there we go. So now I can see the diagram for this. I can see that instead of just person, object, location, entity, right? I have patients, providers that are a person. I know, right? I know that a person can work for an organization. a patient can be diagnosed with a diagnosis, right? Like all of these things that may be relevant. And the interesting thing is now when I apply this ontology to my entity extraction, is that I can see I get very like much more relevant types of memory that are extracted, right? So like, let's take an example that is specific for our domain. So here's one that I copied from another example. So I think, hey, I'm this doctor at this hospital, right? Like I have this patient with this diagnosis, this medication. If I'm applying the like healthcare specific ontology for this, I'm going to end up with a memory that looks something like this, right? I have Marcus Holloway. Well, he's a patient. Dr. Sven Bjornsson, he is a physician. I know that this patient was referred to this provider. I know that like this is the diagnosis, right? I have much more relevant information, right? This is now like the medication that was prescribed for a specific diagnosis. If I go to, something like here, let's load our conservation, right? If I run the same message through the conservation ontology, right, which is about like wildlife conservation, right? So I have like sites and species that are protected within sites. I'm going to have like a very different and much more illogical memory graph that's extracted, right? Like it's much thinner. It doesn't make as much sense. Like yeah, I can tell these are people and there's a location, like, but
Yeah.
right. So anyway, that's an example, like a very simple one. But the idea is, so let's activate this healthcare ontology. So now this healthcare specific ontology is applied, and those that entity model will be enforced sort of by the extraction and resolution process.
So I have a question for you, Will. I'm sure some of our followers, some of our people in watching the webcast today might be wondering, what if I have my ontology built in Prodigy or any of these kind of RDF-based formalisms? Is there any plans or any ideas on supporting those? Because I suppose these ones you're using your own kind of JSON serialization or YAML. I didn't check, but any thoughts on that?
Yeah, so you're right. We have like a internal representation of these ontologies. We're using, if it's interesting for folks, where did my mouse go? The format that we use is well, actually it's in the docs here. It's in here in this page. In the create context graph, I'll drop this in the chat. We use kind of a YAML structure. There's a bunch of examples in the repo that captures like the data model, but because we're also looking at capturing the decision traces, we're also storing decision traces, some kind of like parameterized cipher queries that we can expose to the agent as tools, a system prompt, some configuration for the visualization, right? So it's more than just like the graph data model is the format we use. But yeah, so your question is like, okay, how do I import things? And yeah, so it's meant to be easy to import really any format that you should want. So there's this like auto detect importer. You can upload file from URL or just paste things in here. And so initially these are the formats we support. I say one thing you'll notice is like in different Neo4j tooling, we have ways of representing graph data model and ontologies, right? So one example is like in the Neo4j GraphQL integration, right? Uses GraphQL schema definition language to represent the graph model. But we also folks might use like arrows.app to diagram like a graph data model. But then for things like RDF, Turtle format, we should support. So here's like a simple person works for company example. We can load that. Let's give this a name. Imported. Should we try a more complex example?
I was gonna suggest. I mean, it's not horribly complex, but I'm gonna put one on the chat. It's one that open it first because that's from one of our previous episodes. Is a simple art ontology that we've used in some episodes in the past, and it defines well, just a couple of entities, but a bunch of attributes and relationships. What you get, you probably will have to go to the raw because otherwise it will serve with that URL. It will serve. Well, you copy paste there, right? So what?
Oh yeah. How you? Or we can paste in the URL. That should work. So let's go to.
Oh, you can pass URL.
Import from URL.
Oh, cool.
Auto detect. Let's see what we got. One issue I realized is we don't render the graph viz, because that's what I want to see is the graph view of it until we create it. Anyway, so this is what we got.
That's it's not horribly complicated, but yeah, it's the one about. Remember, Alex, it's the one with the I think it was the
plaques, right?
The Tate Modern.
Oh, it was the Tate Modern
catalog,
one.
Right?
Oh, yeah.
Artists with artworks and artists influenced by others. I think there's some attributes. I mean, some properties in nodes as well that I don't know if they would have been imported, but yeah, that's pretty much it. I mean, we have more complex, but it looks like it works well.
So name, yes. What did I get? Name.
Yeah.
Type. Artist created by. Should we see if this works for our? Let's test a domain specific sample.
I think in that one we had some. I mean, I can even pass you from the same episode. If you get the the GitHub repo that where the ontology was. If you go up one level on the. So if you go to one more level up, so you will see that there's some data folder, and you will see some text fragments. I mean, these are basically the information in the catalog. For some of them might be a bit long, but
nice.
This is the. So
would this be a good one to try?
Yeah, I mean, I think
let's try it.
Any other one? So that's literally the description of the artwork that was in the Tate Modern catalog, and yes, I think it should have at least some, the author, the.
So we should get the artist influenced another artist.
Yeah, not in every single one, but maybe hopefully the one that you picked got something interesting there. But
okay, a man dressed as a harlequin.
So that's one of the.
I don't see anything about. Yeah, I don't. About influence, but yeah, cool. Let's see what we got. So we got. Oh, this is my previous one. That's
right.
Something.
Yeah, it's a. I mean, it's a bit long. I mean, you probably pick one of the longest ones, but.
Let's try a different one.
But if you take maybe one of the Hockney ones. might be more manageable. Maybe the first one, or image of Celia or something.
Let's see. Imported this one. This is our art one. Cool. Let's try that again. So and this is just a preview. We can also we could also activate an ontology, and then we could like see what this looks like in one of the MCP clients, or what this looks like when we integrate this with one of the agents. I should say one of the things like to think about, because this takes like several seconds to run, is this is going through the full pipeline. So we can see like these are the entities, and it will tell us like what stage it was last touched, which was the LLM. So we could turn off the LLM, and honestly we'd probably get something similar. Like the like Gliner model is like quite good. I usually actually have that turned off, but okay, here's what we got.
Yeah.
So we have like Picasso.
That typically influences Hockney. I suppose I can't read because it's a bit small from here, but is there influences?
So this says that Hockney influences Picasso, which I think may be the wrong direction, right?
I would have expected the other way around, but yeah.
And then here's a good one, because we didn't have strict mode turned on, right? When we do the import, we can choose to do strict or permissive. If we did strict, we would have just had relationships in the ontology. So here we ended up with Gregory Evans was an assistant to David Hockney.
That's great.
Yeah.
And then some artworks. That's pretty cool. Yeah, that's great.
And also notice the one thing we didn't talk about was the enrichment piece. So we have this description, which can come from the memory system. We can also pass it through like LLM enrichment, where we ask the LLM to enrich the entity, or we could wire it up to our own internal system. I think by default, the Python package will use Wikipedia, but there's just kind of, or Wikidata rather, but there's just kind of an API for, I want to enrich this in my own system, that sort of thing.
Very cool. We are already a little bit over time. And I wanted to get maybe one more question in before closing the episode. That comes from Dan. Dan asks, how do you assess the quality of memory to ontology extraction, particularly the accuracy of entity classification and ontology mapping? Do you use any benchmarks, gold standard datasets, or other evaluation methods for this?
Yeah, I think that for memory specifically, there are some public benchmarks out there like Locomo, long-term eval. These are some of the public ones. There's a bit of discussion, I think, in the memory ecosystem that the public benchmarks, questioning how relevant they are, because the models have improved significantly. That on benchmarks that are maybe 6 months old, like a lot of the models can score quite highly, and so the approach of like, well, structuring competency questions, like what's most relevant for like the problem that I'm actually trying to solve, is one approach. The ontology specific extraction, I'd say that's one that we're and other folks, I think, in the sort of ecosystem are actively exploring, and I think we'll see some interesting research out there. But yeah, I would say that's part of the challenge is the systems are evolving quite rapidly, that it's difficult to use the public benchmarks to have any sort of like meaningful comparison. That I think the approach of like, what are the competency questions. Does this meaning relevant, like specific for the problem I'm solving, and is this approach relevant to a different one? But I don't know, Jesus, does that match to kind of the pattern you're seeing from customers and in terms of sort of how they're evaluating these systems?
It does, yeah. I mean, to be honest, in some cases it's much more rudimentary, and they just have a collection of test cases, and they run with that. But yeah, that would be the typical approach. Yeah.
Cool. Well, maybe before we drop, I can just give another plug for NAMS, our Neo4j agent memory system, memory.neo4jlabs.com. If anyone wants to try it out, it's available now. Just really appreciate feedback that folks have. Let us know if this is something useful for you, solves the problems that you have. Give it a try.
Yeah, absolutely. Link is I posted it in chat, but it is also in the YouTube video description. So go to that link that is there. And if people want to give feedback, is there an easy way to give feedback? GitHub, or are you having is there like a forum?
GitHub, GitHub is good. There's the community forum. I added it this morning. It hasn't deployed yet, but there is also an in-app feedback feature. There's like a little button that you can click and give us any feedback you want in that. So that should pop up later today.
Cool. Perfect. Yeah, I think that's it. One more thing before we leave you all is obviously the next stream, and that's going to be on the 9th of June, so next week already, where Jem Lamont from our engineering team joins us to talk about the Neo4j Gen AI plugin, Embed Search Generate. Is the possibilities that you get with that plugin directly within Cypher. So that should be an interesting episode, and yeah, join us then on the 9th of June. And yeah, Notes is coming up, and the call for papers for Notes is still running until the 15th of June. So that gives you another, let's say, 2 weeks. Not really, but basically. And you have time to submit for that. We have started to feature a couple of speakers already. Very interesting set. We got a lot of submissions already, but if you are interested in sharing your graph story, please do so until the 15th of June. Registration is open already if you want to just to get the reminder when the event goes down in November. But yeah, I think that's it. Thank you very much, Will and Jesus, for this great episode. Thank you for the demo. I think NAMS looks like a pretty cool space and a pretty cool application. Very interested what people are building with this and what the feedback and experiences are, and hope to see more of this in the future.
Good stuff. Thank you, Alex.
Thanks, folks.